Hello students, welcome back to Madhvi's Java programming tutorials. In this video, I'll be explaining you type conversion, implicit as well as explicit conversion, and calling methods of one class in another class. Let's see the contents. Introduction, types, implicit conversion, Java programs based on implicit conversion, explicit conversion, and Java programs, calling methods of a class in another class. Let's start. Introduction. Converting a data type to another data type. From one data type to another data type is known as type conversion. This is a very important concept so that programmers can prevent loss of data or guide the computer. Conversion may be from one primitive data type to another type, object, second one, object to primitive type, third, primitive type to objects. In this video, we'll be concentrating on the first one primitive data type to another type conversion. Second and third are explained in wrapper classes video. Now, converting one primitive to another except Boolean. How many data types are there? Byte, short, int, long, float, double, character, Boolean. Boolean does not participate. Data types. Please watch the video. Link is given in the description box. Now, integers to floating point numbers. Byte, short, int, long to float and double. From float to integers, floating point numbers. Then character to integers and floating numbers, vice versa. But character cannot be converted to byte or short. Object to primitive type, second one. String is a class. So strings to integers and floating point numbers. Then third one, primitive types to objects, that is integers and floating numbers to strings. This is also possible. Now, types. Two types are there. Implicit, second one is explicit. Implicit means from lower data type to higher data type. It is automatic, means Java compiler does it for us. Lower to higher, which is known as wider conversion coercion. Second one is explicit, from higher to lower type. It is programmer dependent. So if we understand implicit, that is automatic conversion, then when the need arises, programmer can guide the computer to change the just implicit conversion. I want the output like this. So we need to understand as a programmer implicit, what the computer does for us, Java, so that we can guide the computer. This is programmer dependent, explicit. It is also known as narrower conversion, typecasting, using the typecasting operator parenthesis. Implicit conversion means storing the contents of smaller data type variable to the bigger data types, which we know. It is based on two things. One is based on storage and second one is data types. Now what is storage? Byte is 1 byte only, which can fit in short, that is 2 bytes. Character 2, but this character cannot be converted, which we'll see. Now int is 4 bytes, so byte and short can be converted to integer, long, float and double. The second rule is data types float and double are considered as bigger than all integer types, especially int and long we are interested in. Because int is also 4 bytes, long is 8 bytes, float is 4 bytes, but float is considered as bigger than long. Because integer means no decimal part. let's say some 4 is stored. In float, 4.5 can be stored. So which is bigger, 4 or 4.5? 4.5. So Java can accept a long variable in float. We understand two things. One is based on storage. Second one is float and double are considered as bigger data types in Java. Now implicit conversion, byte to short, short to int, int to long, long to float, float to double, no problems. Now character cannot be converted into byte and short, but it can be converted into 4 other types. Let's see 2 Java programs. One is character is not allowed to convert into byte short. Second, byte can be stored in double also, float also, long also, int also. And short can be converted into, and short also, short, and so on and so forth. Let's see Java program. Now implicit conversion. Class implicit has 2 static methods. Means they can be called from only class. Fine. In this character to others method from class implicit, something like that. Char ch is equal to a. A is stored in ch. One single character, single quotes. Literals, integer literal, character literal. Link is given in the description box for literals also. Now, this variable being 2 bytes can be stored in int 4 bytes, long 8 bytes, float 4 bytes, double 8 bytes. So, j is equal to ch. Compiler understands. Java compiler does this conversion. A Unicode is 65, so it takes 65 and happily stores over here. Similarly, long float 65.0 will be taken. This is also implicit conversion. Whenever you store a number, if it doesn't have a 0.0 for float and double, Java does it for us very happily, no problems. So we are understanding what implicit conversion, what Java does for us. Now Unicode value of character ch is, ch means character A. In int is 65, in long is k, 65, that is k variable, L variable, M variable, 65.0, 65.0. Let's execute and see this program. From implicit, it is a static method, char to others. From implicit, it's a static method, so it is available to class only, char to others. Unicode value of character A in int long float double is 65, 65, 65.0, 65.0. Now go back and try to store in short. We are just understanding what Java does. It says error incompatible types. Okay, let's make it a comment. Comments. Fine. Byte control K. Again gives error. So character cannot be stored in shortened byte. Fine. Now let's go to next part. Byte A equals to 3, short B is equal to A, int C is equal to A. What is this? Byte A is a variable, stores some 3. Range, you know how much we can store. Link is provided in the description box. Now B, short B, 2 bytes can hold A, no problems. Int 4 bytes can hold 1 byte of A data and so on and so forth. Here 0.0 is added. Control K doesn't give any errors, means Java allows all these things. So let's go back to our PowerPoint slides. So we understood this particular slide. Let's go. Now, resultant data type is decided by Java itself. What is it? A resultant data type? It is based on higher data type of the operands in the expression. You know storage, byte, short, char, int, okay, all those things. Now, any operator can be used here, plus, minus, multiplication, greater than, operators operands. Link is given in the description box. Now, int plus char in the expression, the operands data type. One is int, second one is character. Then Java decides, okay, int 4 bytes, char 2 bytes, so I'll give the answer in int data type. Then int plus int, second one. Fine, it gives an integer. Int divided by int also gives an integer. Int plus float, I told you float is bigger than int according to Java. So answer will be given in float. Long plus float. Then float plus int plus double plus long. It decides the resultant data type to double, which is obvious. But last line, byte plus short is int. Byte and short cannot be used in expressions if there is any operator used. Always they give an integer, unary operator. Now, we have explained that. Byte and short, there is a unary operator which makes it int. Fine, promoting byte and short to int. Okay, fine. Byte plus byte is also int, short plus short also int, byte plus short, any combination will give integer. Points to be noted by the programmer when we leave this implicit conversion concept. First of all, it converts lower data type to higher data type without the programmer's intervention. Example, int a is equal to 3, b is equal to 2. Double c is equal to a plus b. But a plus b are two operands. A and b are two operands. Plus is happening on integers. A and b are integers. So answer will be integer. But we are trying to save in double C. So 5.0. This is also done by Java only. Stores. Now char C is equal to A. It's a character. But we are trying to store in int D. So Java understands. Okay, I'll store the Unicode value in int D, that is 65. This is first part. Second part is it decides the resultant data type of the expression. Just now in the previous slide we understood based on the operand type. Int x is equal to 1, y is equal to 2. Double result is equal to x upon y. Answer will be 0.0. Why? Because x is integer, y is integer, 1 upon 2 is 0. But we are storing in a double variable. 0.0 will be stored, but not 0.5. So let's see a Java program. Really it is doing like that or not. As a programmer, we should understand. And then how to change 0.0 to 0.5. That is explicit conversion, we'll understand. Now, in implicit, we are seeing one program, that is problem in division. It is a static method again. A is equal to 5, B is equal to 2. Division, some slash T. This is escape sequences. Then A by B. 5 by 2 is 2. 2 2s are 4. 2 will be displayed. Even if I store in division in a variable double, A by B, it sees the Java compiler implicit conversion, int divided by int is int. So 2.0 will be stored. So here 2 is the answer. Here 2.0. Okay, control K and then execute the same program. Problem in division. Integer data type 2. Double data type 2.0. We want 2.5. Now, let's see, we have seen Java programs, explicit conversion. Higher data type to lower data type, and programmer does this. That means double, a bigger value we want to store in long, float, int, short, byte or character. Again, long to character, float, int, short, byte. It's like a small bag is there and we have a piece of paper which cannot be folded in the other way. So we fold in such a way round and keep it there. Similarly, clothes can be folded properly and fit in the smaller bag compared to the object we have. Similarly, explicit conversion does that, but programmer helps. In explicit conversion, 2 points we need to know. First one is storing the contents of a higher data type in a lower data type. It is possible with the help of typecasting operator. Typecasting operator means parenthesis. Inside that, we specify the data type we want. For example, double A is equal to 3.9. I want only 3, that is integer part. So double is a bigger data type, 8 bytes, but we want to convert into integer, 4 bytes. So what I say is, before A, int x is equal to, before that A storing, parenthesis integer. That means I want only the integer part. This is explicit conversion, typecasting operator. So this will store only integer part from A, that is double 3.9, integer part is 3. Second is to alter the result given by a Java compiler. This is very important. We were getting 2.0, int A is equal to 5, B is equal to 2, divided by sign, we were getting 2.0. So, double C equals to double of A by B. Double of means what? A should be temporarily converted, contents of A should be converted into double. What is there in A? 5. So, 5.0 divided by 2. Then implicit conversion. Java sees, okay, double means 5.0. 5.0 divided by 2. I need to give the answer in double. So it gives 2.5. This explicit conversion or typecasting operator can be used either first operand or second operand. See that second one, double Z is equal to A upon double B. This is also results in 2.5. Then second one, char is equal to A. It's a character literal. Literals. Link is given in the description box. Now A to Z 6590 and A to Z 97 to 122. Lowercase. Uppercase, lowercase. This is a very, very useful conversion. Why? Because if you see some of the applications, when we type in lowercase, automatically once we complete, it converts into uppercase automatically. This conversion is done by the programmer using this particular statement for every character. That is loop. We will see little later on. Now CH plus 32. Why? Because the difference between capital A and lowercase a is 32. Capital B to lowercase b, again 32. 32, 32, 32 difference. 97 minus 65 is 32. So if you want to convert from capital to lowercase, we add 32. From lowercase to uppercase, we deduct. This 32 is an integer literal. Now, what we do is, we use BODMAS here first of all. CH plus 32, whatever you get the answer, integer. That is by default, implicit. It tries to store in integer only, but I want to alter. I don't want integer. I want a character which is of 2 bytes. So what we do? Char we specify in the parenthesis. That is typecasting operator. So first of all, BODMAS add them. It becomes 97, I know that. That 97, please convert into character and store it in CH. Now we need to understand parenthesis. It is used in 3 places. First one is BODMAS. That is CH plus 32. First of all, you do it and then the answer you do. convert. So BODMAS, second one is typecasting operator, which we have seen, and method defining and calling. The previous video was talking about defining and calling only. Now let's see Java programs using explicit conversion plus calling methods of a class in another class. Explicit conversion, I have written some 5 methods in this to make you understand what is explicit. See, the division problem can be tackled like this: a is equal to 5, b is equal to 2, double rest is equal to double of a by b. Immediately, division result in double data type, that is a divided by b, that is 5 divided by 2 is 2.5. Control K. And this is from explicit. Division is the method, static method. So explicit, right click, you can see the static methods. Division. Division result in double data type is 5 upon 2 is 2.5. So the implicit way is changed by the programmer using typecasting operator. In some other way also we can do. For example, simple interest is there. PRT by 100. P is integer, T is, let's suppose, time, rate, PRT by 100. Because this is whole divided by P into R into T whole divided by, I use BODMAS here. But all 3 are integers, divided by sign gives integer. So either I can use typecasting operator, or if there is any literal, integer literals video, I can add 0.0. But I cannot add here. This is a variable a.0, b.0. There is no validity to this. So if there is any integer literal or any other literal, we can make this statement give double result. P into R into T, 5000 into 5 into 2, and then divided by 100.0. So one of the operands is double. So answer will be given in double. So the answer, principal P, rate is this, time is this, simple interest is SI. SI is PRT by 100. Control K. Execute simple interest static method from explicit. Simple interest, principal 5000, rate 5, time 2, and simple interest is 500. Fine. Now let's go back and see the third program. That character program which I have explained, tag ch is equal to b, system.out.println, uppercase character is b, ch plus 32 BODMAS, typecasting, store it in ch, after converting it will display lowercase b. Control K, it's a static method into 2char. I'll explain, I'll execute this into 2char. Uppercase is b and lowercase b. Fine. Let's go back and understand double to other data types. This is actually explicit, means a bigger data type can be converted into or stored in lower data type. So double is the highest, bigger data type. We are storing 65.3. I want to convert into a byte. Byte of A. A is the variable. Explicit conversion. Stores in K. J, short type. So convert into short. What? A. Int I, store, long, float, char. It takes only the 65, returns A. So this is the program. Control K, doesn't give any errors, means Java accepts this particular thing. We are using explicit conversion here. Then comes, here is an interesting program. Program to display integer and decimal part separately. Let's suppose 3.49 is there. I want to store in one variable 3, another variable 0.49. So how do I do that? Part 1 is explicit conversion integer part from number we have taken, that is 3. Part 2 will be number minus part 1. Number is 3.49. Part 1 is 3.49. We are expecting 0.49 to be stored in P2. Then part 1, part 2 we want to display. Control K. This says, look at this. This is not a static method. This is an instance method available to the object. So I need to create an object called deci_int. Fine. Close this. Explicit. There is no deci_int. It is an instance method. So I create an object and deci_int I'm calling 3.49. Integer part is 3. Decimal part is a double number floating. It can increase, decrease, anyway. Let me go to options. Clear screen I don't want because I want to show you the changed one. 0.49 only I want, not a floating number. So how do we do that? We use math class here. Open editor. We can use math.round function. What is the function? Math.round. Any number with precision multiplied by 10, 100,000, whatever it may be, divided by 100.0 will give you exactly that much precision. If I want one digit after the decimal, then into 10 divided by 10.0. Two digits, 100 divided by 100.0. Here we are expecting two digits after precision, not 0.490000 something like that. So this math.round is explained in math methods, some lesson number 30. After that, I am printing P2. After rounding off to two digits. Control K. Close this and go to explicit. This is an instance method. So go call deci_int. Now if you see the previous output 3.49, 0.49002, but it is restricted to 0.49. That's why they are known as floating numbers. It can be increased, decreased. Floating. Double and float are known as floating point numbers. Now this is the correct output after math.round. This is about explicit conversion. Now calling. I want to call some of the methods from this class, some of the methods from this class, which are static. And also one method we have written, that is instance method. Now let's see how to call. Now let's see how to call these methods. What are the methods? Let's call only division and simple interest. In calling, this name can be anything. So simple interest is a static method, can be called from class itself. What is the class name? Explicit. So I go to calling and I say Control V first of all. Calling. This parenthesis is used in calling. From what? Explicit. Explicit dot operator. Now dot operator video in the description box. Now explicit dot simple interest. Second one, Control K, no errors. Second one was division, I think. Explicit dot division. And it is a method, so parenthesis. Control K, no system, no syntax errors. Now I want to call from implicit also. Let's see, is there any? See, there is a line. Calling is using explicit conversion, explicit class. Now in implicit, is there any problem in division? Is there very easier one? We'll see. No problem in division. Okay, control K, escape sequences. I want to call this particular method from implicit, from class implicit in calling. So implicit control V, first of all, semicolon, the method name, but from where? If I control K, it says there is no method found because it is given in implicit. So implicit dot class name dot. So no problems. Now I want to see there is one more line. That means this class is using two classes, calling two classes methods. Now let's go back to this explicit only. There is one instance method, decint. We want to call decint, but it cannot be called from class. Let's try it. Control V, semicolon, after calling parenthesis with. Let's suppose I just say implicit dot, control K, gives an error. It says undeclared method because, okay, it is in explicit. Let's change control K. It says non-static method, so I cannot call. In that case, we need to create an object of explicit class. Explicit E1 is equal to object creation, new explicit calling constructor, right? Object is created, E1 dot decint, no problems now. So we are calling static methods from explicit class, two static methods, one static method from implicit class, and one instance method from explicit class. When we execute, four methods output would be there. One is simple interest, second one is division, third one is problem in division, fourth one is decimal to integer. So this was showing the previous one also. Let's clear this once, clear screen at method call and execute one more time. We want to see only four methods output. Okay. Principal, that is simple interest. This is division. This is problem in division. Then this is converting integer part and displaying integer part, and so this is how we do execute. Refer chapter 3 of Basics in Computer Applications for further understanding and practice exercises. And the next video is very important, input in Java. So far we have taken input as parameters, but now we'll use scanner class to take input. This is how a Java program is written. Thank you.